So we've looked at expanding harder brackets and working with harder expressions when it comes to the binomial theorem. What I'm going to do in this video, I'm going to give you two examples. What I'd like you to do is pause the video, have a crack at the two examples, and then come back here and check your working against what I'm going to show you in here. So here you go. So the first example I want you to do is I want you to expand the bracket 1 plus x squared, all squared. And then the second one, slightly more complex. I've got 1 minus 3x cubed, 1 plus 2x plus x squared to the power of 4. The product of them, I would like you to expand all of that. So pause the video, have a crack at these two questions, come and check what you've done. So the first one was 1 plus x squared, all squared. Now remember, for expanding anything in terms of the binomial theorem and the binomial expansion, we have to have it written in this format. X plus y to the power of n. Now the n power outside, so that's fairly obvious, it's the 2. Now remember, when we did the example of this in the original video, what I did was I split up this expression in here in such a way that I could take the x squared, make it the equivalent of the y part of my expression here from a binomial expansion, and the 1 plus x, and make it the equivalent of the x part of my binomial expansion. So then I could expand it the same way using the same rules. I would maybe just have a bit more of a fiddle to do afterwards in terms of expanding a couple more brackets and simplifying it down. So if I was to do that, I'd expand it using the same rule. So I'd use my binomial coefficients. So I'd have 2, 0 for the first one. I'd then have 1 plus x squared. I'd then have plus 2, 1 times the 1 plus x times the second part here, which is the x squared. I then have plus my third part, which is the 2, 2 binomial coefficient, times my x squared squared. So all I've got to do is multiply out each of these, take the coefficients into account, and then I'm laughing. So multiply out the first, so 2, 0, we know that coefficient is 1. We know the 2, 1's coefficient is 2, and we know 2, 2's coefficient is 1. So I've then got 1 times this expansion. Well, if I expand 1 plus x all squared, I end up getting 1 plus 2x plus x squared. So there's my first term there. I've then got plus, so I've got 2 times the x squared, so my coefficient outside 2 times this x squared, multiplying out this bracket here. So my second part of my expression becomes 2x squared plus 2x cubed. Close it off. I've then got my third one, so 1 times x squared squared, which is then just plus x to the power of 4. Remember, multiply the two indices together, and we get x to the power of 4. Now that I've got that, all I need to do, gather all the like terms together and simplify. Doing that, I get 1 plus 2x. I've then got x squared plus 2x squared, plus 3x squared, plus 2x cubed, plus x to the power of 4. There you go, nice and straightforward, following the way we want to do it. Using the binomial coefficients, expanding the two parts as my x and my y, and then bringing it all together. So that was a slightly easier example than the next one to follow. Second one was this. So I had 1 minus 3x cubed times 1 plus 2x plus x squared to the power of 4. Now remember, for this one, what we do is we do each of the brackets separately and then bring them back together as the product of one another to do the final set of expansions. So the first one I'm going to do is this one here, my 1 take away 3x to the power of 3. Now remember, we need it as x plus y in the bracket for a binomial expansion. So I'm going to rewrite this as 1 plus negative 3x to the power of 3. So I know the x part of the expression would be 1, the y part would be negative 3x, so it takes the sign into account. And then expand it the same way. So I'd have 3, 0 times 1 to the power of 3 plus 3, 1 times 1 squared times the negative 3x. So there we go, the negative sign's coming into play. I've then got plus 3, 2 times 1 times the negative 3x all squared, and then plus my 3, 3 times the negative 3x all cubed. Now for each of them it's great because we can essentially ignore the 1 to the power of anything, because that's always going to be 1. Focus on the coefficients and what happens with the x's. So 3, 0, I know that's 1. 3, 1, I know you're 3. Same with the 3, 2, I know that's 3. And then the 3, 3, I know is 1. So there we go, we've got all my coefficients. So 1 times 1 cubed, there's a difficult challenge for you. That's 1. I've then got 3 times 1 squared, so 3 times negative 3x. So that then gives me negative 9x. I've then got plus my 3 coefficient here times my negative 3x squared. Well, negative 3 squared is 9. So I've got 3 times 9x squared. So I then get plus 27x squared. And then my final term is just given by the negative 3x all cubed. So from that, I get minus 27x cubed. So that there is the first bracket. Second bracket I'm going to expand is this one. Now, this is similar to the one that we did before. I've got 1 plus 2x plus my x squared all to the power of 4. And what I'm going to do is split it off and have 1 plus 2x as one term and x squared is the other part of the term. So when I expand it, I look at my binomial coefficients. So I get 4, 0. That's then going to be times 1 plus 2x to the power of 4. I've then got plus 4, 1. That's then going to be times my 1 plus 2x cubed, but it's then times the x squared, so this then starts to come into play. I've then got plus 4, 2 times my 1 plus 2x. That's now gone down to a squared, but I'm then multiplying that by the x squared squared. I've got my next term, which is given by 4, 3 for the coefficient, times the 1 plus 2x. The power's now gone down to 1, so I can just leave it as 1 plus 2x, and that's going to be times my x squared cubed. Oh, running out of room. Then plus my final term, coefficient is given by the 4, 4, and then it's just going to be times x squared to the power of 4. Go through this, do each term individually, and then bring it all together. Don't overcomplicate the thing for yourself. Looking at the coefficients first, well, 4, 0 gives me 1, 4, 1 gives me 4, 4, 2, 6, 4, 3 gives me 4, 4, 4 gives me 1. So what I can then do is I know that this one here, the coefficient is 1, it's just given by the expansion of 1 plus 2x to the power of 4. Now, you can take this to the side and do a binomial expansion on that one as well to make it slightly easier for yourself. When you do that and you ultimately simplify the whole thing down, what you'll end up getting is 1 plus 8x plus 24x squared plus 32x cubed plus 16x to the power of 4. So that there is my first set of terms, so that's given by this. I've then got my second set of terms, so I've got 4 times the x squared, so I'm going to have 4x squared, and if I expand the bit in the bracket, the 1 plus 2x all cubed, I'm going to end up getting 1 plus 6x plus 12x squared plus 8x cubed for that term. I've then got my next term here, given by the 4, 2 times the x squared squared. Well, x squared squared is x to the 4, so that then gives me 6x to the power of 4 times 1 plus 2x squared, which is just 1 plus 4x plus 4x squared. I've then got my third term here, my fourth term here, which again, if I expand it, I'm going to be looking at doing plus 4x squared cubed is x to the power of 6 times 1 plus 2x. And then I've got my final term, x squared to the power of 4. I've then got plus x to the power of 8. So if I expand each of these terms on their own, if I've got things outside the brackets, first term is going to stay the same, so I've got 1 plus 8x plus 24x squared plus 32x cubed plus 16x to the 4 First term's going to stay the same. My second term, everything's going to get multiplied by 4x squared. So I'm then going to get 4x squared plus 24x cubed plus 48x to the 4 plus 32x to the power of 5. Sort the next term, I then get plus 6x to the 4 plus 24x to the 5 plus 24x to the 6 from that term. My next term, given by this bit here, I get plus 4x to the 6 plus 8x to the 7, then plus my final term of plus x to the power of 8. So that's a lot of terms, and now what I have to do is bring all the like terms together and simplify it. So if I do that and I bring everything together, I end up with 1 plus 8x plus 28x squared plus 56x cubed plus 70x to the 4 plus 56x to the 5 plus 28x to the 6 plus 8x to the 7 plus x to the 8. So that's that one there. Now that looks fun, but can you imagine doing that without the binomial expansion? That would not be a fun operation to do. What I now have to do is I've got to remember that I'm then multiplying this by the first part of my expansion here. And this is where what we do is set up a table involving both, multiply everything in that second expression by each term on its own from the first, and then we simplify them using column sums. What I do is I set up a table similar to this. So this set here, this column here, is each of the terms from my first part of my expansion. What I'm going to do is take each of these terms and multiply the second bracket expansion by it. What I then do is I can set this up in columns, total them, and I get my final simplified expression. So if I take each of these and multiply the second expansion by it, I end up getting a table that looks something like this. So I've multiplied the whole of the second expansion by 1 to get here. I then multiply the whole thing by negative 9x to get this row, plus 27x squared to get this row, and then minus 27x cubed to get this row. What I then do is go down each of the columns, totaling it up, and then I get each of the simple parts of my expression. So quite simply, if I do that first one, all I'll get is 1. There's only one thing there. If I then go all the way along, I'd have negative 9x plus 8x. I'd then do the total of this column, working my way along the entire set of the table. And if I were to do that, I'd end up with an expansion that looked like this. 1 minus x minus 33x squared, take away 7x cubed plus 106x to the 4 minus 658x to the 5, take away 1148x to the 6, take away 622x to the 7, take away 1247x to the 8, take away 669x to the 9, take away 189x to the 10 minus 27x to the 11. Now that's a mouthful just to say. The binomial expansion, yes, it actually looks like it's more complex, but has made our life a heck of a lot easier. Could you imagine trying to multiply all of that out without some sort of technique like this to make your life slightly simpler? We have to make sure we can do this on much more difficult expressions and sets of brackets. That's the way we apply the binomial theorem and the binomial expansion. So make sure you can do these types of examples, look at the work in the textbook, have a crack at a few more, and just make sure you can follow the steps and the logic the whole way through.